You're two-thirds of the way up the long side of the grade, loaded heavy, the turbo screaming, and your eyes keep dragging back to the one needle on the dash that actually decides this. The pyrometer, walking up past 1,000 degrees and still climbing. And here's the thing nobody tells you the first time you watch it happen. That number feels like the truth, not a malfunction, just a limitation built into the physics of the gauge itself. Because the temperature it's showing isn't quite happening right now. It's already a step behind. You're reading something that just happened. Every driver who ran mountains before the electronics took over knew that gauge, and most of them never fully trusted what it was telling them. For good reason. The pyrometer doesn't read the fire in your cylinders in real time. It can't. The probe that takes the reading is a chunk of metal stuck in the exhaust stream, and metal takes time to heat up. It has thermal mass, so the needle always lags the engine, reporting a temperature your exhaust hit a moment ago, while the actual heat inside has already moved on, usually higher, on a truck that fuels hard, a motor that can slam from cruising to 1250 in a matter of seconds. The gap between what the needle shows and what's really happening in the engine can open up quickly, especially on a hard pull, even if the gauge is only trailing by a short margin. And that gap, small as it sounds, is the difference between a long climb and a melted piston. The needle tells you the truck was fine, but the truck might not be fine anymore. Every old hand learned to drive ahead of that lag instead of behind it. You didn't wait for the needle to scare you. You watched the grade, watched the load, and backed off the fuel before the gauge ever caught up, because you knew that by the time it caught up, the verdict was already in. The drivers who got hurt were the ones who trusted the needle as a live readout, who held the hammer down because the gauge still looked okay, not understanding that "still looks okay" on a pyrometer is a sentence with a delay built into it. The smart money learned to read the road instead of the gauge, and to treat the needle as confirmation of a decision it had already made. That's the cruelty of the instrument, and it's there before you even get to the worst of it. Because the single most important thing this gauge ever does for you has nothing to do with the climb at all. It happens after you've already won, after you've crested the grade, after the strain is over, when you're sitting dead still with the engine idling and your hand reaching for the key. We'll get there. Sit with the dread for now, the way a driver had to. Start with the simplest question, the one that sounds dumb until you actually think about it. Why this gauge? A truck dash has a dozen needles on it. Oil pressure, water temp, boost, voltage, fuel. Why is the one that determines whether you make the grade a thermometer stuck in the exhaust? The answer is the whole reason diesel guys and gas guys argue past each other. A gasoline engine has a clean, simple way to know if it's running safe. Air-fuel ratio. There's a target number, the engine lives near it, and you can watch it. A diesel can't do that, and it drives the gas crowd a little crazy. A diesel's air-fuel ratio doesn't sit on a number. It swings across an enormous range, extraordinarily lean when the engine's just loafing along, far leaner than anything a gas motor ever sees, then pushing hard toward its fueling limits the second you stand on it and start pouring fuel in to climb. There is no single air-fuel number that means safe, because the number is always moving and the engine is happy across a huge spread of it. So, the diesel needs a different proxy, something that tells you not what the mixture is, but what the engine is actually suffering. And one of the most useful real-time measures of how hard a diesel is straining, how close it is to hurting itself, is heat, how hot the exhaust comes out the back. That's why, on a long grade with the hammer down, the pyrometer isn't just one gauge among many. It's the one that's actually answering the question you care about. Is this engine going to make it, or is it cooking itself to get you to the top? Now look at how the thing pulls off the trick, because this is where it stops being a gauge and starts being a little unsettling. On a traditional analog pyrometer, there's no battery behind it, no power wire feeding the needle. Nothing in your electrical system drives that reading. The gauge is powered by the exhaust heat itself. The probe is a thermocouple, two wires of different metals welded together at a single tip. When that tip gets hot, the junction of those two dissimilar metals generates its own tiny voltage. It's called the Seebeck effect. And it is doing exactly what it sounds like, turning raw heat directly into electricity, no help required. The voltages are small. For the common Type K probe a truck uses, you're looking at something like 5 millivolts when the tip's at boiling, climbing to around 29 millivolts up near 1300 degrees. That's it. That whisper of voltage is what swings your needle, which means the gauge keeping you alive on the grade is being driven directly by the very heat that's threatening to kill your engine. The danger is generating its own warning. And it gets stranger because a thermocouple doesn't measure absolute temperature directly. It measures a difference. That little voltage doesn't correspond to the temperature at the probe tip. It corresponds to the gap between the hot tip out in the exhaust and the cool connection point back at the gauge, where the wires land on the terminals. So, the instrument has a problem. To turn that difference into a real number, it has to know how warm its own terminals are, back there behind the dash, and add that back into the math. Engineers call it cold junction compensation. What it means in plain terms is that your pyrometer is quietly taking two temperature readings at once, the fire in the pipe and its own body heat, and doing the arithmetic to hand you one honest number, a gauge that has to measure itself before it can measure the engine. Assume it's doing all that correctly, and you still haven't answered the question that actually decides everything. Where is the probe? Because the same engine on the same grade, pulling the same load, will show you 1300 degrees or 850 degrees, depending on one thing and one thing only, where somebody screwed the probe in. Drivers who ran two probes, one before the turbo and one after, watched it happen in real time. The pre-turbo gauge climbing to 1300, while the post-turbo gauge hung back, lazy, down around 850. The turbine wheel in between is pulling energy out of the exhaust, and the gas comes out the far side meaningfully cooler, typically a couple hundred degrees lower than what hit the turbine going in, depending on load and the turbo. So a post-turbo gauge can sit there showing you a number that looks perfectly safe, while the turbine inlet, the hottest, most fragile point in the whole system, is genuinely cooking. The placement isn't a detail. The placement decides whether the gauge is telling you the truth about the climb or telling you a comfortable story, while the engine quietly comes apart. This is the part that ruined trucks owned by careful men. A driver could do everything right, watch his gauge religiously, never let it cross the line he was told to fear, and still cook a turbine, because the line he was watching was measured on the cool side of the wheel. He thought 1100 meant 1100 everywhere. It didn't. Out in the manifold, where the metal actually lives or dies, the gas was running a couple hundred degrees hotter than the number he was trusting his livelihood to. A post-turbo gauge isn't wrong exactly. It's just answering a different question than the one a man climbing a grade is actually asking, and the truck doesn't tell you which question got answered. You find that out later, in the shop, looking at vanes that shouldn't look like that. So you mount it pre-turbo up in the manifold, where it reads the real heat. And in doing that, you create a brand new way to destroy the engine you're trying to protect. A thermocouple probe lives in the exhaust manifold by having its tip stuck directly into the gas stream. That's the only way it reads anything. Right behind that manifold sits the turbocharger, with a turbine wheel spinning at tens of thousands of revolutions per minute. If that probe tip ever fails, cracks, burns off, breaks loose, it doesn't always fall harmlessly into the pipe. In a worst-case failure, it can be carried downstream into the spinning turbine wheel. There are mechanics who flat out refuse to put a thermocouple in the manifold for exactly this reason. They've seen or heard of the probe that was installed to save the engine turning into a piece of shrapnel fired point blank into the most expensive part of the truck. The gauge whose entire job is preventing a catastrophe becomes the catastrophe. And there's a quieter trap, one that doesn't blow anything up. It just makes the gauge lie to you, and you'd never know. You can't extend a pyrometer's wiring with ordinary copper wire. You have to use matching thermocouple grade wire. Run out of length, grab a roll of copper out of the toolbox, splice it on, and you've just created another junction of two different metals, which means you've accidentally built a second little thermocouple right there in your splice, generating its own stray voltage and corrupting the signal. Read a thermocouple through the wrong wire, and it'll hand you false readings. The gauge tells you a story that doesn't match what the engine is actually doing. The fix is unglamorous, and people get it wrong constantly. The same metals have to run all the way back to the gauge, or the instrument is worthless. A pyrometer is only as honest as the wire behind it. Even when everything's installed right, a single gauge is hiding things from you. And the old Detroit guys knew this better than anyone. Those two-stroke Detroit diesels, the screaming ones, were in some setups fitted with two pyrometers, one for each bank of cylinders. Not because somebody liked extra gauges, but because the left bank and the right bank of those engines could genuinely run at different temperatures, one side working harder, hotter, closer to the edge than the other. And a single gauge averaging them together would smooth that difference right out of existence and tell you a comfortable middle number that described neither bank. A driver watching one needle would think he was fine. A driver watching two could see one bank creeping while the other loafed, and know which side of his engine was about to give him trouble before it actually did. The single dash gauge most trucks carried was, in a real sense, only ever telling you half the story. The men who kept those engines alive for 1,000,000 miles weren't watching that one number. They were watching two and reading the difference between them like a pulse. There's a number every driver knows, and it's worth understanding where it actually comes from. 1,250 degrees. That's the line, the do not exceed, the figure burned into every owner-operator's head as the temperature where your pistons melt. And the reason everybody believes that is that aluminum melts at 1,221 degrees, right there in the neighborhood. So it feels like the universe drew a clean line and somebody found it. It's nearly a coincidence. The max EGT numbers people quote have very little to do with aluminum's melting point, because the piston in a hard-working diesel isn't a freestanding lump of pure aluminum sitting in an oven. It's oil-cooled, alloyed, sprayed with engine oil from underneath specifically to carry heat away. The first things that actually fail when you push the heat too far usually aren't a melted piston at all. They're the hottest, most exposed parts in the system: turbine components, exhaust valves, and the ring seal starting to give up. The number drivers fear is a real danger line. It's just guarding against the wrong nightmare. The piston is rarely the first to die. And then the emissions era arrived and quietly flipped the gauge's entire reason for existing. The single needle on the dash is fading out. Walk up to a modern truck and you won't find one probe. You'll often find 4 or 5 EGT sensors placed all through the exhaust, and almost none of them work the old way. They're usually thermocouples or other resistance-based temperature sensors feeding the engine control module, not a needle in front of the driver at all. The truck reads its own exhaust temperature now, in multiple places, and makes its own decisions. But the deeper change is what those sensors are watching for, because it's no longer just danger. During a diesel particulate filter regeneration, the truck burning the soot out of its own exhaust filter, the system deliberately drives the exhaust temperature up, typically into the 550 to 650 Celsius range, sometimes higher, on purpose, to incinerate the trapped soot. So a modern truck can be sitting there, showing a screaming hot exhaust, reading that has absolutely nothing to do with how hard you're pulling. For 70 years, a high pyrometer reading meant one thing: the engine is straining, back off. Now it might just mean the truck is cleaning itself. The same heat that used to be a warning became sometimes routine maintenance. Which brings you back to the dread we left running at the top of the grade. The one job this gauge does that matters more than the climb itself. The one that happens when the work is already over. You made it. You crested the pass, the load came back under control, the strain's gone, and now you've pulled into the slot for the night, with the engine idling and your hand on the key. Every instinct says, shut it down and go to sleep. And that, right there, is the moment the pyrometer was quietly built to save you from. One reason post-turbo probes became so common wasn't just about watching the climb. It was about this. That turbocharger you just had, screaming at full song, dragging you up the mountain, is still glowing hot. And the oil feeding its bearings is the only thing keeping it alive. Kill the engine while the turbo's still that hot, and the oil sitting in those bearings doesn't drain. It cooks. It bakes into hard carbon deposits, coking the bearing, and the turbo that survived the entire climb starts dying right there in the parking lot with the truck shut off. The gauge that fought you all the way up the grade has one last thing to tell you before you sleep, and it's the most important thing it ever says. Not yet. Let it idle. Watch the needle fall. The mountain didn't kill the turbo. Turning the key too soon does.